Alright, let's talk about something that's absolutely fundamental to every single thing we build. From a tiny watch to a giant skyscraper to the machines that power our world. I'm talking about structural integrity. Think of it like this. It's the skeleton of your machine. It's the strong, rigid framework that holds everything else in its proper place. It allows moving parts to do their jobs without tearing themselves apart. It's the unsung hero, the silent partner. Without good structural integrity, nothing else matters. You can have the most powerful motor, the most precise computer controls, the cleanest fuel, but if the frame is weak, you've got nothing. Like mounting a race car engine on cardboard. The moment you hit the gas, it will twist, warp, and fly apart. The structure is the foundation. It provides stability and resistance to forces, vibration, torque, heat, pressure. Let's get our hands dirty and break this down. When we talk about a machine's structure, what are we actually talking about? The housing, the structure, the frame. First up, you have the frame or chassis. This is the big, heavy-duty skeleton that everything else bolts onto. It's the main foundation designed to be incredibly rigid and absorb massive operational forces and vibrations without bending or twisting. Next, we have components like shafts. Shafts are the rotating backbones of a machine. They transmit power and motion from the motor to the working parts. These parts have to be perfectly straight. Then there are the housings and casings. These are the protective shells that enclose the delicate guts of a machine. A gearbox housing, for example, is critically important for holding the bearings and gears in perfect alignment. If the housing warps, cracks, or gets distorted, those gears will no longer mesh correctly. If the gears are too close, this will result in metal-to-metal contact, and eventually pitting, spalling, and particle generation that contaminates the lubrication, starting the cascade of dominoes. Here's the thing that makes structural failure so dangerous. It almost never starts with a bang. It's a sneaky process. The most catastrophic breakdowns begin their life as something you could easily miss if you weren't looking for it. The number one culprit is the microscopic crack. When cracks happen to components such as fatigue-induced microcracks, it can play havoc on the entire system. These tiny fissures can start from a manufacturing defect. They can start at a sharp corner where stress concentrates, or they can start from metal fatigue after millions of cycles of vibration and load. At first, it's just a hairline fracture hidden under a layer of paint. But with every cycle the machine runs, that crack gets flexed open and closed. Another silent killer is corrosion. We see rust on the outside and might think it's cosmetic. It could be happening inside a housing. Corrosion literally eats away at the metal, thinning it and weakening it from the inside. Don't forget about simple mechanical wear. Over years of vibration, the surfaces can begin to wear down, leading to fretting. Fretting is surface damage from repetitive small motion between two metallic surfaces under load. This friction causes wear, material degradation, and possible component failure, often due to vibrations, cyclic loading, or thermal changes, leading to corrosion and mechanical wear. So you've got a tiny, hidden structural flaw. This is where the magic of failure analysis comes in. It's all about a chain reaction, a cascade of dominoes. Crack leading to misalignment, lubrication failure, contamination, catastrophic failure. The first domino to fall is almost always alignment. A machine is basically a system of perfect geometry. If a frame twists, the motor is no longer perfectly aligned with the pump it's driving. That misalignment puts immense stress on couplings. The second domino is lubrication. Once parts are misaligned, the lubrication pathways get disrupted. Bearings that should ride on a perfect microscopic film of oil are being pushed sideways. That pressure squeezes the oil out of the clearance, causing metal-to-metal contact and large, squealing noise. Think shopping cart with a bad wheel. The third domino is cleanliness. As parts wear, they shed tiny particles of metal into the lubricant. The oil or grease that was once clean is now contaminated with an abrasive sludge. That gritty mixture gets circulated throughout the system like liquid sandpaper. Finally, the fourth domino falls: operating conditions. Let's make this real. Let's trace the life and death of a machine, starting with one simple common problem: a slightly bent motor shaft. Maybe it was damaged during installation, a hammer strike, or it was shipped from the factory with a tiny, almost imperceptible bend. At first, nobody notices. The motor is bolted down. It's coupled to a pump, switched on, a very slight, low-level vibration, not enough to raise alarms. This is the hidden flaw, lying in wait. Weeks go by. That bent shaft, spinning at 1800 RPM, is acting like a tiny whip. With every rotation, it forces the bearings to move back and forth in their seats. The perfect alignment is gone. The load is no longer evenly distributed, concentrated on one spot. The shaft seizes instantly. One quick tip. If you use witness marks on the feet of the equipment, the operator can check for soft foot. This will spot the issue quickly and avert unplanned downtime. This is where you come in. As the operator, you are more intimately connected to your machine than anyone else. You know its personality. You know its normal sounds. You know its normal smells. You know its normal feelings. This knowledge is your superpower. Engineers can look at data and mechanics can take things apart, but you are there for every single cycle, every shift. First, use your ears. Every machine has a signature sound, a rhythm. Listen for any new noises. Is there a new ticking? Finally, and most importantly, use your eyes. Look for the little things. So you've used your superpower, you've spotted a clue, you heard a new noise, you felt a hot spot, you saw a tiny crack forming near a weld. Now what? This is the moment that separates a minor repair from a catastrophic, plant-stopping disaster. Act on it immediately. It's so tempting to think it's just a small vibration. We can finish the run. That thinking is the most expensive mistake you can make. That tiny flaw won't get better on its own. If someone had checked that faint vibration, they'd have found the bent shaft. However, not doing something about it will cost unplanned downtime, perhaps a late customer order. Cost, a few $1,000s, a few hours of downtime. This could have been less expensive had we knew what to check for and acted fast. Be curious, no matter how small, raise the flag.